So, yeah, today I'm going to try something different. So, instead of me just reading some sort of research paper and trying to explain what I have been doing, I'm going to create or more probably solve a system design problem. So, since it's just the starter video, I'm going to go on a lighter note. So, the problem today I have picked is distributed unique ID generator. Now, there's a premise that I have already completed this video and I've already recorded all those stuff. I was first actually thinking of posting that video, but I'm not going to do that. It's approximately like 2 hours of video, just me brainstorming through different ideas. But rather than posting the whole work thought, I am thinking of actually creating a video, which is this video obviously, where I will not only give what I created but the actual solution. So, and as you can, as you know that in system design there is no single solution, it's just pros and cons. So I will be discussing that, not yeah, but there's a disclaimer. I'm not going to discuss from the point of view of an expert. I am no, I am by no means an expert, right? In fact, if you ask me, I'm pretty noob person when it comes to system design. So I have never taken a course, never learned theory, but never worked on a very highly scalable Google level uh, architecture. So I'm still pretty dang new to this whole system design stuff. But it's pretty dang intriguing to me, and that's why I've been reading MapReduce paper as well, because it's interesting to me. So yeah, I think that's the whole idea of the video. You're going to see a person who has pretty much never done system design apart from couple of bits and pieces from the system design interview book, the couple of starting chapters. So yeah, we are going to do that today. You're going to see how a completely different take on what the system design problems videos that you have seen, because those are given by the expert, it is given by a person who is literally an idiot. So yeah, I think so that's what the premise is, and let's just get started. So this was the actual problem statement. I'm gonna go through it very quickly and maybe just give me a TLDR or summary. Okay, so yeah, bro, it literally gave me. I asked it to give me a summary, it literally gave me the answer. So it was a bit of spoiler, but then again, it doesn't matter. So yeah, because I already know the answer, I already read the answer as well. So yeah, I'm going to just go through the problem solver. You are designing a distributed system that needs to generate globally unique IDs at a very high scale. The system will be used by multiple services running across many machines and data centers. Each service may need to generate ID independently or without making a network call for every ID. So this line pretty much gives me a lot of idea. But before I give my ideas, I'm gonna go through how I will run through this video. So first and foremost, I will dissect the problem statement and will show what I was thinking. So I will show first my solution, and then in parallel I will also give the right solution, whatever the right solution is, and that's how I will go through. So I will give my solution and then I will give the actual real solution, pros and cons and design. Okay. So when I actually first encountered this statement, I thought to myself that okay, if I don't need to make a network call, it's pretty much need to be embedded in the service or in the component. But since I need to generate the ID independently, I can easily think of something like UUID. Sorry. So yeah, I can just think of UUID. So my basic premise was okay, I'm gonna take a service which will be embedded, which could be embedded in some other systems or in some other services, and it will just give out the UUID, and that was my whole premise. I could just wrote a couple of line of code which will return me UUID and make it a jar and push it to the services which require it. Now that was the that was my initial thought, and I discarded it because to me it didn't. I didn't see it like a system design solution, because in system design, like from what I know, people draw hundreds of boxes, API gateway, all those stuff like load balancer, reverse proxy. It was like mind-boggling to think that such a easy solution could be thought of as a system design problem. But there was a catch, and the catch is in the functional requirements. So my train of thought was not exactly incorrect. It's just that I had to read their requirements. So the first requirement was generate every ID must be globally unique, which it does satisfy, because UUID generally and statistically should be unique if I am given a relatively smaller time frame, and that smaller time frame is a large frame in actual technicality. So yeah, that's one thing. The system should support generating ID at a very high throughput. I mean, it doesn't matter to me because now I'm embedded into a service and I can generate UUIDs at really high speed. It's just that I have to, in the worst case scenario, do multi-threading and pull out multiple threads to generate UUID, but that doesn't matter because we don't have any sort of service which will be a bottleneck. It's just a service embedded into other service, so it should be okay, right? I'm not sure about millions per second, but yeah, I think it should be good enough. IDs should be generated. Anyways, I never know like what this means. Like, how am I able to actually give exact number? I'm not sure. I think there's some chapter at the very starting of the Alex book, the system design interview, but I skipped that, so I probably need to read that again. Read that again. Then third is ID should be generated in distributed manner, no single point of coordination per request. And that's good because we know we do not have a single point of coordination. But there's some other train of thought I had as well, which I'm going to discuss a little later, which had this problem. So yeah, just keep that in mind for future. Low level latency, so it should be verified it's ideal in memory. Current solution is in memory. The system should continue working with even if some nodes are data center go down. I mean, it should be okay, like as long as service is okay. It should not matter if service is down. I mean, I don't care, right? But but the problem is that, yeah, I think that's good, right? I think that's good. It's just a other component, or probably more likely a fat jar. So yeah, it should be okay. Scalability, add more machine without major redesign. Yeah, the moment we require more machine, yeah, just if we have some extra service, we can always embed it in. Even a single service can have multiple of these UUID generators, so that's not an issue. Horizontal scaling should be okay. We could do whatever we want and it should be good enough. Fault tolerant clock skews, node restart and network partition should not break the uniqueness. I mean, it's a UUID generator. Nothing can break it. Nothing can break its uniqueness, I guess. Not nothing, but yeah, most probably nothing should be able to break its uniqueness. Now here's the catch, like everything till now seems okay and this should be fine, right? And in all actuality, this is a decent enough idea. This is, I'm not going to lie. But the nice to have actually makes this completely incorrect. So first that the idea that not idea the IDs are roughly or timely ordered. Newer IDs are larger, meaning that the IDs should be should have some sort of sortability, I guess, or maybe that one is larger than the other. We should have the concept of this. But if you know UUID doesn't have the concept of this, there's nothing like time frame in it. Well, technically there is a time frame in it, but yeah, we don't have that time order out of box in UUIDs. Second, IDs that are compact fit into 64-bit. UUID just doesn't fit into 64-bit, it fits into 128 bits. Reason being because each of the character of UUID is actually hexadecimal, so that's 16 bits. And since we have 32 characters and 4 dashes, so 32 character into, wait, 32 characters into So we have 32 characters and wait, I'm not sure like how it is 128 bits. So it has 32 characters and it should be 4, right? So we have 32 character, each character should be 4 bit. Oh yeah, okay, I was completely wrong. So yeah, it's 128 bit because a single carry is a hexadecimal. Hexadecimal could be represented in 4 bits, right? I was multiplying it by 16. I thought 32 into 16 should be the answer. Now since a hexadecimal character should be of 4 bits and we have 32 of those, so it's 32 into 4, which is basically 128. Okay, I was afraid there for a second. No dependencies on central database or in auto increment counter. Okay. Then we have constraint multiple data across multiple region. Experience machines may experience clock drift. They will eventually experience clock drift. You can assume machine has a unique identifier. You may design how to assign one. I mean, we can do it with the pattern that we use in hashing and all those stuff. Yeah, but that's doable. Language and storage are your choice, and okay, blah blah blah, doesn't matter. So that's the problem statement. So the first solution I thought through and which I said out loud is that we can have an embeddable service in other service which just generate UUID is a decent one, but it doesn't produces nice to have. It's not roughly timely ordered, and it is not, more importantly, compact. So okay, we have to think of some other solution. hmm The so before we go into the other solution that I have to say that this is one of the solution, uh, and it's actually a good one from the even from the real solution book, even from the real bookish knowledge, I would say. So, but then again, it had the same problem that I had suggested. It doesn't follow the nice to have that we have in business requirement. So that's boring, but that it is what it is. Then moving on to the another solution. Another solution would be to have a single basically a single server which will have auto increment counter, and each of the web service, basically what I'm saying is, okay, let's just go through here. Let's just say we have, or not this, let's just say we have this. This is your generator. So this is a generator. Then we have couple of extra servers, web services. They will ask, yep, they will ask this ID generator to actually produce the IDs, right? Now this ID generator in itself uh, can have some sort of counter, which is atomic counter, maybe with lock and mutation and all those stuff, and it will ensure that whenever in basically it could start with 0, and whenever a new ID has been generated, it will be increasing its counter to 1, and when another ID is generated, it will increase its counter to 2. So basically we have auto increment counter, and each of the web service that requires ID generation, it will call this a generator, which will increase the counter and provide the ID back at the web service. Now this is not bad because it's solving the issue. It certainly is in 128 bits, and it is certainly uh, time ordered, because we know that the smaller one is the one that has been created earlier, and the one that has larger number has been created a little later. So we have the roughly time ordered, not time ordered, but we have roughly the ordering existing in this as well. And but this doesn't follow the point of having a central database or auto increment counter. So I think this solution is also okay, but this is not the solution that at least this problem is looking for. Now Though I have to say this is also one of the other design that we could have made and is also proposed uh, in your theoretical bookish knowledges, that this is a plausible design. It's also been used in some other companies as well, and I believe it's called ticket server. So yeah, I think this ID generator is called ticket server. Basically, the logic is the same, that we have some sort of counter which it produces, which it passes once the ID is required, and it's also increment the counter. We had just have to make sure that it's atomic, synchronized, and all those stuff. But yeah, that goes right. That's good, right? Except that it has cons. Cons, like I said, it has first single point of failure, and then second, we are generating IDs and we could generate a lot of IDs. So a single server and a single database handling all those stuff, eventually it is bound to exceed that particular server limit or particular DB limit, no matter what we do. So for smaller to medium enterprise scalable company, it's good. Uh, but for the most scalable company, this isn't the solution that they might be looking for. So yeah, that is the other solution that we had. So it is also something which I thought that might be okay, but then again, it's not okay to have. So we can take those two train of thought and just leave it as it is. The third one, which I hadn't thought of, I didn't even encountered my mind, and I'm just going to directly tell the solution because it is in the same line of thoughts as the ticket server, is that we can have something called, which is they call as multi-master. I'm not sure whether the name is right or not. I can check. Yeah, so it's multi-master replication. Yeah, it's multi-master replication, and the theory goes like this. So now this is something which is completely the bookish knowledge. I never thought about it. I probably wouldn't have thought about it. So let's just say we have a couple of web servers. Not this. So I'm pretty bad at Excalibur as of now. So yeah. So we have, let's just say, a couple of web servers, which is one and which is two. And in the back end, we have a, is it a single database or is it a double database? I think it was a single database, yeah. Or is it? No, I think they were double database. That was named as multi-master, right? So basically we have a couple of servers. Let me just get it right once. I'm pretty sure. Yep. Yeah. So let's just say we have a couple of extra DBs, and I will tell you the reason we have multiple DBs. Right. So this is the DB. Now let's just say these are web servers. These are web servers. These are cluster of web servers, whatever you want to call it, and these are basically the database. So now the theory goes like this, that we will we will do the auto increment still, right? Because we know that in database, especially in MySQL and similar database, we have auto increment feature, but generally the auto increment happens by 1. So, and since we have auto increment by 1, if we try to say that okay, sometime we will ask this, sometime we will ask it, or parallelly or concurrently we can ask these databases to hand us out some auto incremented number, which could be called as the ID. It will collide at some point of time, because both of these SQL databases are auto incrementing by 1. So they could theoretically collide at some point of time, even if we try to segregate them as much as possible. Example being, if we start the first one, let's just call it A, let's just call it B, not B. So A and B, if we start A with 0 and B with 10, at some point of time we will collide. A's increment counter will collide the B's past incremented counter, because after 10 requests A will be having auto incremented counter of 11, I mean, sorry, and B will have, I don't know, around 21. But since B started with 0, there will be some collision between A and B. So what's the idea now here is that instead of having the auto increment of 1, we will have auto increment of k, where k being the number of dBs we have. So let's just say, since k here is 2, this means we will have auto increment of 2. Now, since we will have auto increment of 2, we can assign A with starting value of 1 and B, no, maybe, and B with value of 2. Yeah, I think that's okay. So if we start with A as 1 and we auto increment by 2, so whenever we will have a new ID request, it will provide the ID but also increment it, so that it will make it 1 plus 2, which will make it eventually 3. 3, then next time it will have 5, then 7, then 9, right? Similarly, this will be 2, then this will have 4, then 6, then 8, right? So in this manner we can have non-collision increments, but they are still auto incrementing and they are not colliding. So that's also a okay way. Now you might be thinking that, hey, this happened here in case because k was equal to 2 and we had odd even segregation, but that's generally not true. Like, it might be possible that we could have some collision due to multiples of some sort of other numbers, when we have large number of I would say servers, right? So in that case it's not that hard, right? So we can just create a replica of this. We can demonstrate it with C. Let's just make the k as 3. Now it will be incrementing as 3. We can make this as 3. So 1 plus 3 will eventually give us 4. Then it will have 4, then it will have 7, and dot dot dot. Similarly, this will come out to be as 2 comma 5 comma 8 dot dot dot. Similarly, 3 will come out to be 3 6 9 dot dot dot. So in this way, as you can see, that it, since we are just adding a number, we're just adding k to the auto increment counter, we can have the segregation from the starting point, and in this manner we can create the auto increment incremental counter and provide us some sort of global unique ID. But it is still not the best solution. A, because it literally follows does not follow a nice to have, which is auto increment counter. But second, it is that it is a little bit harder to scale. Well, you can obviously scale it. It's not like it's completely non-scalable. It's just that it's a little bit harder to scale, because if we want to actually add or remove the servers, now this means our k is going to be changing, and which will make the calculation migration a little bit odd, because now we will have to calculate with or basically with an updated k, which will cause which might cause some conflict with the incrementing counter difference, and that could cause some issue. Maybe we need to migrate that, but that's also another issue, right? So this is the issue we could face with it. So that was the major issue that this has. And frankly speaking, there's one more problem, that it is a relatively hard problem to I think this is purely from my side, that I'm not sure how we can actually say that okay, these are the two indexes, which one of them has been placed a little bit after the other, meaning it is a little hard for us to say that this is a time order range. If I given as 1 and 4, I know that 4 has been produced later, 1 has been produced a little bit earlier, but I'm not sure about how I can say it between 1, 2 and 3. That's a little harder for me to say, especially, or maybe 4, 5, 6. I'm not sure. So like we have some sort of confusion here. Obviously they could be solved with a little bit more advanced algorithm, but then again this will be becoming a little bit more complex for what something that is literally disqualified due to the not nice to have. Okay, but that's also a solution we just have to keep in mind. Now okay, so this was something which I was thinking, when I was creating a video. I was thinking out loud, so that is something I wrote. Yeah, and then the last thing that we have to actually think is something interesting. So right, so now you might be thinking, hey, I talked literally about everything except for something which should be really obvious. When I say time order, it says that hey, just goddamn use the the time stamp, right? And you're correct. We can and we should probably use timestamp, right? But the problem with timestamp, just using timestamp is, let's just say, okay, I have two servers. Let's just say I have two servers, and both of the let's just say two requests comes up here concurrently. Uh, then the timestamp won't be working because the timestamp will be same, and there will not be any uniqueness, right? So you might be saying, okay, yeah, in that case let's just do what we can do. Maybe since we already have some sort of name or some sort of identifier, maybe we can also add the identifier of the machine, right? So id of machine, right? So we can also add id of the machine, and that's partially true as well. We can add the id of the machines as well, but what would happen? Okay, by the way, also let's just yeah, so this is, I call the machine A and this is the machine B. So yeah, we can add the ID of the machines as well, but but the problem is, let's just say, and this is a little hard problem to think, let's just say I have a server. Let's just denote it with this also. Let's move this a little bit upward. Yeah, so let's just say, for now, okay, I'm going to delete it. Let's just say this is a server. I call it as, I don't know, S. So let's just say first the server S asked a ID from the machine A. So machine A generated it using the timestamp and the ID of machine. Now what we do is, that seems fine. If after some time I call the request from the B, it will have a different unique ID because timestamp A will be different and also the machine ID of the machine. But let's just go back to the A again to think what would happen if this service actually do multi-threading and calls for the ID concurrently, right? So basically what I mean to say is that we can have a situation where the same server asked to the same host machine that what asked to the same machine but via two concurrent requests, via multiple concurrent requests. In that case the timestamp will be the same and the ID of the machine will also be the same, and that's a hard problem to solve. But that's one problem to solve if you think about it, but there's also another problem to solve, right? Let's just remove concurrency for now. Let's just say I have another server, and this servers also ask this server also concurrently happens to have request from server, both of the server actually happen to call the node A at the same time. In that case, our unique identifier will not be unique because A, it's the same timestamp due to concurrence request, and B, ID of the machine is also same. Then what should we do? I think it's easier to say that we can just have these server assign their values as well, and we can just add it to the I guess the ID list or ID generator. So you can say server ID, right? Now this is also solved, but we still haven't solved the issue of concurrency one, right? So what would happen in this case? And I came to the conclusion that I have to somehow provide each request a ID of its own, and that's why I chose that. Since it's an API call to the server specifically for ID, I thought that each of this particular request will contain the process ID as well, the process which is used to trigger this particular API call, and I can add it to the process list, to the generator list, and in this way I can make concurrency. In this case, I can make the concurrent request from a single server to a single node unique as well, because it will be, what will happen is that these particular requests will be concurrently coming from the concurrently coming from the concurrently coming from different processes, and that process ID will probably make sure that we have different IDs. We have different ID generated. Okay, I hallucinated there for a second. Yeah, so that was my final solution. That was my final solution to the whole stuff. And if you understood it, congratulations. It was not easy to follow. I know that my explanation is not that good. Yeah, but the thing is, like, this was my solution, right? Obviously this is not the official solution, but the official solution comes a little closer to what we are trying to solve. So the official solution goes like, hey, yeah, just use timestamp, right? So timestamps should be, let me just come up here also, let me just copy it here, make the segregation, yeah, because we won't forget. Mine official, right? So yeah, okay, my bad, I forgot. Yeah, that should be good, right? Or maybe we can actually do this a little bit bigger. I think that should be good. So if we go with the logic of, okay, yeah, we have timestamp, then how, what would, okay, so timestamp is there. Now we probably need to add the server machine ID and the server ID, not the machine ID and the server ID. You can, we have to probably tweak it a little bit, because currently what happened is that here we are having some sort of network call from our server to the machine node, which is certainly not required, because it said that it doesn't need to do a network call, and that's why we had to have a solution where we would embed this node into our service. So this will basically look somewhat like okay, I'm gonna just remove this. So also this will probably look a little bit like, this will probably look a little bit like this. Yeah, so this will probably look a little bit like this, that we have our generator service embedded into the actual web service. Now let's just come up here. So now you might be saying, okay, then in that case, how will we actually provide the IDs of this and of this and of this, right? So first thing first, like, the ID web server is really easy. It's the same thing. So previously we had S1, it still has S1, so I would say ID of the web server. For now that's there, right? Now you might be saying, okay, uh, it's still the ID of the machine, nothing wrong, and you're correct. But if you think about it, in the question we were provided we were said that we would have multiple data centers. So what we can do is that since basically they are now a single unit, we could aggregately have an identity for them. And how would that identity work? Maybe for each of the data center we can have a data center as its ID, and then we can assign IDs, just an integer ID, to the individual machines in that particular data center. So let's just say let's just say we have two machines in say single data center. So we have two machines in single data center. Let's just say this data center number is wait, why? Sometimes I'm not even sure like how Excalibur works. But anyway, you get the gist, right? So let me just copy it here. Let me just move it here. Take this and also copy this. Copy this, copy this, copy this. So right. So now these two data center are different. So each of them have a different data center ID, and each of these machines will individually have unique integer value as well as identifier. So example could be, I'm not sure why I'm not able to write it. So I can just go here and I can do D. There's no like I can do this. I'm not sure. I'm so confused why it doesn't work. Anyways, right. So let's just say we have 0 and we have this. So we have assigned the ID to the data center, and we can also assign this like this. We can assign these individual machines as ID as in normal integer ID as well. So now how will we actually identify this particular machine? We can say, hey, its data center ID is 0 and its machine ID is 0. So basically we have 0 0, then we could have 0 1, then we could have 1 0, then we could have 1 1. So this will eventually how it look like. So bro, I just don't understand. Yeah, so now instead of the machine ID, it will probably have the data center ID, and instead of the ID of web server, we will just say that it's the ID of the service, which is the same thing. So now we have three things defined. So that's okay, and I will probably remove this because I don't like this. And you are getting the hang of it, right? Now we are trying to draw the parallels. What is happening, man? So now you're getting the hang of it, right? Because we are trying to draw the parallel between this stuff which I have created and the actual solution. Now the only thing required is to actually have the thing I called as process ID, right? Because I had to solve concurrent requests from the same server. But if you think about it, this solution is pretty much a completely wrong solution, because in actuality there's nothing like a request here. It is completely called out that we should not have a network call. Meanwhile I did that completely because I was too stupid, I guess. Anyways, the point being that we don't necessarily have to solve it only on the basis of request request information or process ID, because there is just no network request or process ID. So now question is like, what would happen if the same service calls for the embedded node at a similar time, at the same time. And the idea is pretty dang simple. It's just to do what we are trying to do from the very beginning, just do it auto increment. So if you know about it, what timestamp is, so chat, let's just go to ChatGPT. What is timestamp when we use something like get timestamp in Java? Let's just think. So timestamp is basically a representation number that defines a specific moment in time. When you something like get time, which usually means the number of milliseconds per unit since the Unix epoch, right? And this is all the stuff, blah blah blah. The main point is basically timestamp is a number which we get, which usually means the number of milliseconds that have passed from this time onward. So if I do current time, what it will does, it will first check the offset value, then calculate the total number of milliseconds, and it will print me the milliseconds. I think that's the logic, right? If I'm not mistaken. So returns the value since, yeah. Okay, so that's good. Now, since it's generally based on millisecond, obviously we could do it nanosecond as well. But since it's based on millisecond, if the processes which are, let's just say, concurrent, if they happen to even be a little bit different in milliseconds, even if there's 1 millisecond difference, we know that our unique ID will look a little different because the timestamp itself will be different. But what would happen if they both lie on the same millisecond? And since we don't have network calls and all the stuff, I will not try to I will not try to get the answer from the network request information or even process ID. Maybe we could try to do that, but let's just leave it as it is. We maybe can think of in the lines of what we are used to trying to do. So let's just say if both of the request in quotes lands on the same millisecond, what we can do is we can just simply have some sort of counter for each of the millisecond, saying, hey, if a new millisecond start, reset it to 0. If not, like if we have many and many requests in the same second, I will just act as a normal increment counter. So from the starting I will be 0. Let's just in the same millisecond, if we have one more request, then I will be becoming 1. If we have one more request in the same millisecond, I will be becoming 2 and 3 and 4 and so on. So what would happen is that we will have timestamp for the very first request, let's just on the x millisecond. We will have timestamp, we will have data center ID, we will have the ID of the service, and then we will have 0. Then for the second request on the same millisecond, we will have data center ID, timestamp, ID of the service, and then we have 1. Then for the third one, in the same millisecond, we will have all the three things are same, then but the last part will be 3 and 4 and 5, basically going forward and so on. And whenever a new timestamp, whenever a new millisecond starts, we will just reset it back to 0. So basically this means that the last one should be, I'm not sure how should we put it. We should be auto increment counter for milliseconds, right? I think that's a good name. Okay, I think that was small only, right? And I think that's it, right? This makes sense. But this way we are actually generating independent unique IDs which are not interdependent on the services themselves, and we doesn't have to care about anything. Each of the service will be and is capable now of creating its own unique generation it's based on timestamp, so it's sortable on time. We can get the roughly idea of which one has been executed before and which one has been executed after. It's so hard to say sometimes these words. Then we have data center ID and service of ID, which segregates the concurrency that's happening between the two different nodes or two different web services. And then we have auto increment counter for millisecond to resolve the issue that is happening in a single millisecond. Right. Okay. That was too tough to explain. Now, this is not a solution that you could think off the top of your head, because this actually is a service which was developed by Twitter. It's called Snowflakes, and it is basically a distributed system auto ID generator, which basically generates, which basically is a mechanism which let individual service create unique identity based on the timestamp, data center ID, ID of the service, and auto increment counter for MS. Basically, what we discussed here is actually the logic behind Snowflake and how Twitter generates random IDs. Now, there's still a little bit part we haven't discussed yet, which let's just go here. And the part was what happens to 64-bit. So how the 64-bit is actually distributed. So first of all, timestamp is 41 bits. So I will write it timestamp, and I will write it like this: 41 bits. The reason being for it's 41 bits, we can ask GPT what is the total bit size of these timestamp. The reason being and timestamp is always stored in, yeah, it's always stored in long, but what is the exact bit count for this? Okay, GPT is thinking, yeah, so it basically requires 41 bits, right? And the reason being is that we have 2 to the power 40, which is greater than 1760. Basically this generally the epoch time, or not the epoch time, the timestamp lies between 2 to the power 40 and 2 to the power 41. So which basically means that we require 41 bits for this to be represented correctly. So how many numbers can be stored in 41 bits? Okay, nothing. I was just thinking of something else. So right, so now basically the exact count number is 41 bits, because we have the 41 bits. Now if you think about it, basically epoch time is dependent on the 41 bits. So we have the 41 bits here completed. Now let's just make it medium as well. Now we have data center ID. I will call it DCID. And then we have machine ID. I will call it as machine ID. I'm not sure how much time it will, but Twitter decided it should be 5, and it should be 5 as well. Reason being because 5 will basically 5 bits is required. Basically it will mean that we have 2 to the power 5 combinations, which will be 32 data centers and similarly 32 machines. So each center will have 32 machines, and there will be 32 of the data center, which will means that they eventually be 32 into 32 total number of machines. Now the last one remaining is the counter. So counter is the 41, then there's this which is basically 10, there's 51, and we are the Twitter thought of taking it as 12 bits, mm, because that's how they wanted to do it. They wanted the system to be scalable, so even if it means that we have, no, it's not, it should not be 12 bits, I'm sorry, it should be 4151, and then we have, no, it should be 12 bits, yeah, because we want 64 bits, right? So they decided to be 12 bits, because they wanted their system to be scalable, such that even if we have like 2 to the power 12 combination, basically in a single second we can have 2 to the power 12, which should be basically 4096. So which will mean that we can have 4096 concurrent requests in a single millisecond, and the system should be able to handle it. So that's pretty dang large, considering a single millisecond can handle 4096 combinations. So that's okay. And now you might be thinking, hey, that's just 63 bits. So there's one more bit, they call it reversed bit, reserved bit. They call it reserved bit, which is basically 0. They can use it later for future use, for maybe they can use it for thinking that this is a signed bit, this is an unsigned bit. So generally there's a notation of signed and unsigned bit in binary numbers, so they just made one extra bit for future buffer. And this was the whole architecture of how Snowflake decided what they want to do and how they want to distribute their 64 bits into smaller chunks, so that each chunk will have its own value, and they commutatively provide a unique identifier. Oof, that was a lot of information. Also, there's one more thing, like I want to understand, obviously they can increase the 41 bits to maybe a little bit more bits, so they can have more buffer for timestamp. Because let's just say if we have certain buffers, so I want to give some rough idea, that they only give 41 bits to the timestamp. So the maximum number we can have is 2 to the power 2 to the power 41, and minimum number we can have is 2 to the power 40 plus 1 for 41 bits only, right? If I want to fill all these bits thing, right? But since we have okay let me just get a second. This, okay, I need to get this reference again, just a second. Yeah, okay, so I was thinking the same thing, I just got confused. So yeah, we have 41 bits, right? So if we have 41 bits, basically we have 2 to the power 41 combinations, and 2 to the power 41 combinations means that for each of the basically we have 2 to the power 41 milliseconds, which will eventually lead out to 69 years. And that's how Twitter decided. They said that okay, we want this ID to only be resetting after 69 years. I'm not sure why they come up to 69 years only they can think of, right? Maybe they like the number itself, I don't know. But anyways, that's how they decided it. They constrained it in such a manner that they said that okay, for the 69 years we will have certainly good number and the timestamp, then we will reset it, right? Reset will require some sort of migration. Maybe they can even use this res again to switch it back to 1, and they can have one more 69 years. So they will have eventually have, I don't know, like 70, 71, 40, maybe 138 years of longevity. But that's something they decided. So if a company wants that, hey, I want an even longer shelf life, but I don't have much scalability, they can maybe decrease the counter to a little bit lower bits so that they can handle, let's just say, 10 bits only. So it will be 1024 request in a millisecond, but they can use those 2 bits to increase the timestamp one. So timestamp will now have 2 to the power 43 combinations of 2 to the power 43 values that could be used. So that will increase eventually a lot of time. I think that was everything I actually had to tell, right? So let me just cross check once again. Like I said, I'm not an expert. I'm just a noob who is trying to understand, and I'm creating video what I understand. So even if there's like things me things like me looking at very basic stuff, so please pardon me. I just need to check some more things. Oh yeah, there was one more thing which we forgot. I just remember, not this one. Maybe we can remove this. It says that it would be better if we handle clock skews, and since we are using timestamp, it will have a clock skew, right? So it will certainly have clock skews. This machine will somehow drift from this machine. This machine time will not be reflected exactly with this machine time. They will have some sort of difference, and that's the clock drift or clock skew. And that happens because like each of the machines have their own hardware clock, and these clock are generally quartz clock, and they can have a little bit inaccuracy. So these inaccuracy pile up sometime, and they can clock difference in the exact time between two different computers. So one strategy to actually think it is to actually have NTP, I believe. So it's network time protocol. Basically what happens is in network time protocol is that we take a bunch of servers, and these bunch of servers are used as the real time, and we take this real time, and we have our system we want to synchronize, and we take the real time and synchronize them with these systems. So one example of NTP could be GPS. So we take the GPS time and synchronize it with different machine. That's how we do it in our mobiles as well, right? We have a mobile connected to GPS, and it try to synchronize time with it. That makes sense. So this also means that in future, that if let's just say a machine uh, uh, quads is a little bit faster, let's just say drifted far in future, and NTP says that hey, you have drifted far in future, this is the exact time. Let's just say it says that there's 42 seconds, and it says the NTP or GPS says it's 41 seconds. So what synchronization will do, it will roll back the time. So from the server's perspective, it will think like, oh, we had 43 seconds, then suddenly we have 41 seconds. This means we have traveled back in time. So, and if that happens, then again this algorithm could break, because we will have similar timestamp. 41 second has happened before, now we will again be back to 41 seconds. So that could cause some issue. So yeah, we have to just basically think like how we would implement NTP, and maybe we could do a gradual rollback instead of direct rollback on whatever we can do, and maybe something completely different for NTP. So that's the thing we could use for synchronizing the clock. uh, yeah, but that's for real damn good accuracy, right? We have to actually understand the constraint, and I actually got this video from one of the other videos in YouTube. They said that we actually have to understand the constraint before trying to apply the NTP and the other stuff. They had faced a similar problem of ID generation, and for them the best solution was to actually have a single source of truth, and this single source of truth will just generate uh, incremented counter one. Basically they almost recreated ticket server approach. because it works best for their team. So it doesn't matter like what the best approach is. We can obviously have 100 of hours discussion of theory, but in the end what matters is that the practical constraint is required. And having the clock synchronization, I believe, is hard. Obviously I have never done it, but I believe it's hard. So maybe we can actually delegate it to something else. And I'm not sure, like maybe uh, yeah, but purely from the perspective of the question and not going to something else, we have to probably do NTP to actually have the clock synchronized, or uh, with maybe gradual rollback, or maybe we could use monotonic time. I'm not sure. Like this is the part which is a little bit ambiguous to me as well. I'm not gonna lie, because the resources I looked at, they didn't go that much into depth that how this particular server system should be cross synchronized. I believe NTP should be fine, but it's hard to do. So we have to rely on the constraint. If this constraint could be a little bit more non-strict, we can tweak our system and maybe try to make it better. Otherwise, just implement NTP or maybe use monotonic time to uh, as a fallback for the NTP direct rollout or rollback. So yeah, this is this is the nutshell of what ID generation should look like. I'm not gonna lie, I'm tired. I talked a lot today. Okay, anyways, that was it for the video. So yeah, I think this video was decent enough. I guess it was around 20-25 minutes long, or maybe 30 minutes long, but I think I covered what I wanted to cover. uh, I think so. Yeah, I think like it's past 1 here, right? It's more than midnight, so I think I will take my leave, and I will do some rest, probably sleep, and I hope you enjoy the rest of your day too, or night, or whatever it is. Hope you enjoy whatever you have coming up in your life. Bye, I'll see you in the next one.